Hello, my name is Simon. I'm a PhD student at ETH Zurich, but I'm based here at CERN, and I work with the FASERng experiment. So FASERng is an experiment at the LHC where we try to detect neutrinos that are produced from the Atlas collision point. And we're located about 500 meters away from Atlas in one of the tunnels that connect to the LHC. And the way we detect these neutrinos is by using photographic films called emulsion. And these films are very good for detecting neutrinos because they have a very, very high precision where you can see tiny, tiny tracks that when a neutrino interacts with our detector. The thing is that because we use film, we need to process we don't have any electronics, so we need to develop these films in order to get the data out of the actual film and digitize it. So this is done here in the Emulsion facility at CERN, where we develop the films. And in order to develop the films, we hang the films that are about this size, so about an A4 paper, on these racks. And then we put these racks in the developer liquid, which are placed in these kinds of tanks. And in order to do this effectively, we need to align the film to be as horizontal as possible to these clips here that we use to hang the film. So we were struggling a bit to hang the films and make it as horizontal as possible. So then we used the 3D printing and prototyping facility at IdeaSquare to develop these so-called jigs. So this is just 3D printed with one of the 3D printers at IdeaSquare. And then what we do is that we hang it to one on this edge of this rack, and then we can very easily, using the notch at the bottom of this jig, align the film so that it matches here and then is as horizontal as possible, and also height-wise so that it matches the perfect height so that it's submerged into the liquid and not sticking out of the liquid, because if the film is sticking outside of the liquid, it wouldn't get developed and we will lose the data on that edge. So that's what we did. So we attached this jig to the edge of this rack, tried hanging the film. Then we did some modifications to make sure that it was long enough, that it fit to this rack, and iterated back and forth using the 3D printers at IdeaSquare. And then we could come up with a working jig that perfectly matched our rack and our films. After that, we used it to develop a lot of films last year in November. In total, we have about 730 films that we need to develop each time, and it worked very well. And this year as well, as part of the last run of the LHC Run 3, we also have a box underground in the LHC right now as we speak, taking data. And we will take that out of the LHC in June, and then we will also develop these films using the same rack system and the same jigs. So that's what we have been using this for. Thank you.